On this channel, we provide useful programming information with practical code examples. This time, it's about JavaScript and WebAssembly. We will explain the basics of WebAssembly and take a closer look at the relationship between JavaScript and WebAssembly, as well as their use cases. Enabling subtitles will make the code descriptions easier to understand. JavaScript and WebAssembly, WASM, are crucial technologies in web development. Each has a different role, but together they complement each other to enable faster and more efficient web applications. WebAssembly is a binary instruction format executable in browsers, generated from compiled high-level languages such as C, C++, and Rust. WebAssembly executes much faster than JavaScript, providing web applications with performance comparable to native applications. WebAssembly has the following features. High performance. Because it is compiled into a binary format, it runs very fast and excels at CPU-intensive tasks. Language agnostic. You can generate WebAssembly from compiled languages such as C and Rust, making it easier to port existing native code to the web. Wide compatibility. Major browsers such as Chrome and Safari support WebAssembly. WebAssembly is not a replacement for JavaScript, but a complementary technology. JavaScript excels at UI manipulation and network communication, while WebAssembly handles compute-intensive tasks. By combining the two, you can achieve both performance and flexibility. WebAssembly modules can be invoked from JavaScript. JavaScript can access the memory and functions of WebAssembly modules, enabling scenarios where complex processes are executed in WebAssembly and the results are received and processed by JavaScript. Below is a basic example of loading a WebAssembly module from JavaScript. In this example, a WASM file is fetched, and its binary data is passed to the WebAssembly instantiate function for instantiation. You can call the exported functions of an instantiated WebAssembly module from JavaScript and retrieve the results. Next, let's look at a simple example of how to call a function that performs fast integer addition in WebAssembly. First, we create a simple function in C that will be compiled into WebAssembly. Compile this file using Emscripten, a tool that converts C, C++ to WebAssembly. Then, call this function from JavaScript to obtain the result. In this way, computational processes can be executed in WebAssembly, and the results can be manipulated in JavaScript. WebAssembly is well suited for compute-heavy workloads such as video processing and physics simulations, delivering performance that JavaScript alone cannot. WebAssembly is particularly useful in the following scenarios. Game development. WebAssembly provides the high-speed computations required for browser-based games. You can implement physics calculations and advanced graphics rendering engines in WebAssembly, while handling the interactive parts with JavaScript. Video and audio processing. Large-scale media processing, such as video encoding, decoding and real-time audio effects, also benefits from WebAssembly's performance gains. Scientific computing. Compute-intensive simulations and data analysis can also be greatly accelerated with WebAssembly. Examples include numerical analysis and the execution of machine learning models. Porting existing native applications. With WebAssembly, you can run existing native code written in C or Rust in the browser. This allows you to leverage existing software assets and offer them as web applications. WebAssembly is very powerful, but there are also some constraints and challenges. Limited DOM access. WebAssembly itself cannot access the DOM directly. JavaScript acts as an intermediary, allowing WebAssembly to focus on high-performance computation. Difficulty of debugging. Because WebAssembly is a binary format, debugging is more difficult compared to JavaScript. Browser development tools do support debugging of WebAssembly, but it's not as straightforward as debugging JavaScript. Learning curve. Using WebAssembly requires knowledge of compiled languages such as C and Rust. If you are not familiar with these languages, the hurdle to learning WebAssembly can be higher. WebAssembly complements JavaScript's flexibility and enables near-native performance in the browser. By letting JavaScript handle UI and dynamic interactions and WebAssembly handle computation, you can leverage the strengths of both to the fullest. By combining the two, it becomes possible to develop faster and more advanced web applications. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. See you in the next video. Please subscribe and give us a thumbs up.